Coming up to the last machine operation on our cylinder heads, and that's going to be resurfacing the gasket surface where it meets the barrels.
Hi and welcome to Classic ATS. During this 8-part series we're going to show you how to fully build your 911 air-cooled cylinder head.
Now at this point you should go over the heads one last time, recheck all the threads, recheck the spark plug threads, chase any thread that needs to be rerun before you perform this last operation. This is because you don't want to sit a cylinder head into a milling machine or on a drill bench to drill out a stud on a freshly machined cylinder head gasket surface. So when it comes down to machining the cylinder head sealing surfaces, the tolerance on this is extremely important. This is because we have 3 individual cylinder heads being mounted to one side of the motor. So if we have a different height between each cylinder head, we run the risk of not having a good combustion seal on the cylinder. So the first thing that I want to do before I start machining our cylinder head sealing surface is I want to measure the actual cylinder head thickness right now. The specification is 87.1 millimeters. That's the overall thickness of the cylinder head. There's 2 different types of cylinder head sealing surfaces. The first one I'm going to cover is going to be the 1965 to 1969 2 liters, and then I'll cover how to measure the 1970 through 89 model cylinder heads. So what I've got here is I've got our cylinder head set up on our granite block, and I'm just using a digital height gauge. I've cleaned the surface where it's going to sit, and what I'm going to do is I've already zeroed my height gauge. I'm just going to bring it down and measure to the gasket surface and see exactly what kind of a reading I get. Now we are looking to see if these cylinder heads have been machined before. Porsche says you can only machine 0.25 of a millimeter off the cylinder head. Now this is true, and it can also be false. The reason why they say 0.25 of a millimeter is because it is affecting a compression change and a height change in the motor, which we can accommodate for by using a larger copper sealing ring. If we needed to machine the cylinder heads, if they'd already been machined once and were already 0.25 of a millimeter under, then we could machine the surface again, but we would have to use a custom copper shim to maintain our compression ratio and height specifications. So once I've made a measurement, what I usually like to do is flip the cylinder head over, and then just on the gasket surface right here, I'm just going to write whatever number I got. So this one was 87.09. So pretty close to the specification. The specification is plus or minus 0.02 of a millimeter. This way it just gives me a starting point so I can verify it when we get over to the lathe that my machine is zeroed correctly, because I'm going to use my lathe's DRO or digital readout system to track how much material that we're cutting off. I can also see I've already gone ahead and measured these heads, and you can see on there where I've written this one's 87.05. So we just finished measuring the early 2-liter cylinder heads. On the 2-liter cylinder heads, the sealing surface is right here on the outside boss of the head. On the 2.2-liter engines and up, so that's 1970 models and up, they recessed the sealing surface down below the cylinder head. This is because they switched to a different type of barrel seal that was going to be more efficient. Now dimensionally, both of these cylinder heads are the same dimensional thickness. If we measured from the cam box sealing surface to the boss on the bottom of the cylinder head, both of these heads should measure 87.1 millimeters when they are brand new. The difference is when we machine the 2-liter head, we are machining this surface down 0.25 of a millimeter. When we come over here and machine this type of cylinder head, we need to machine this surface. We're also going to machine this surface out here, but our sealing surfaces right here need to be within 0.02 of each other. First thing I'm going to do is I want to see where all my cylinder heads are at. So I can't measure using my height gauge. I'm going to have to use my 75 through 100 millimeter micrometer. When I put the micrometer in, I want to bring it in and I want to make sure that the anvil on this side is going to be up against the cam box surface. And then I'm going to screw it down in on the inside surface and take the reading. Now this is where it is a little uncomfortable because you need to make sure that the micrometer is square. Otherwise you are going to get a false reading. And you want to make sure that your micrometer doesn't drop off your cam box surface. So the specification new is going to be 84.48 millimeters. So that means that this particular cylinder head has not been machined before. The reason why we want to check all 6 cylinder heads is we need to make sure that none of the other heads have been machined. You cannot machine just one cylinder head and place it back into service on a motor. So there's a number of different ways that you can machine cylinder heads. I usually do them on our lathe. This plate here is just a custom piece of aluminum. It was actually a scrap piece of aluminum that I was able to get from a machine shop. And it's being drilled for the cylinder head studs as well as the locators. I'm using a 4-jaw chuck. The 4-jaw chuck allows me to center on the combustion chamber, which I have done. So when the video's running, you'll see some offset running on this, which is normal. That I'm not concerned about, but I am going to be centered on the combustion chamber. Then up here I have my DRO. Right now I'm touching the tool cutter off against the gasket surface, and we are at 87.09 millimeters. If we pan back and take a look, we can see that this cylinder head measured up at 87.08 millimeters. Now there's some surface distortion around here when I rotated the cutter, and I measured it in 4 different places using my tool to touch off, and at one of the 4 points it did actually hit the 87.08 millimeters. So don't be surprised if you do see some slight differences when you're touching off. So there's 2 surfaces that we want to machine. This is our primary gasket surface on this cylinder head. Our other surface is going to be down in below here. Now this surface on the 2-liter cylinder heads is not used as a sealing surface. It is only where the barrel comes into this recess. But whatever material we take off here, we have to take off from down on this surface as well. So normally what I'll do is I will come in and machine this surface first, and then I will move over and machine the second surface, only because if I need to take a little bit more off of this, if for some reason, like if there was a lot of damage here and I had to machine a little bit more off of this surface, I need to know how much to take off of this second surface. So the first face has been machined 0.25 of a millimeter under. So if we take a look at our DRO, I have 86.85, which is 87.1 minus 0.25 of a millimeter. Now I'm going to pull back in and I'm going to touch off here, which should be the same as our later style heads, 84.48, and I'm going to reduce it by 0.25 of a millimeter as well. This head is done. Now we've just got to make sure that we maintain our tolerance, cutting the other 5 cylinder heads, and everything stays within plus minus 0.02 of a millimeter. So I have the latest style cylinder head chucked up in the lathe. On the 2-liter heads, you saw me machining the gasket surface, which was like out on this boss area. Now what I'm going to be doing is I'm going to machine, this is our gasket sealing surface right here. I looked at all of the heads on this particular batch. This one has the greatest amount of wear, and you can just kind of see that groove. So I want to go ahead and machine that one first, make sure it cleans at 0.25 of a millimeter. If it does not clean, then I need to be able to machine all the rest to whatever it cleaned up as, and then we would have to adjust compression with custom copper base gaskets. So it looks like this one's cleaned up at 0.25 of a millimeter, so I'm going to go ahead and machine the rest of the heads in this batch. The last step in the machine process is I'm going to deburr all of the holes. When you machine the cylinder head surface, a little bit of the material gets pushed in and it makes this surface sharp in here, and it can also hang up on the stud. It will also create a weakness level if you don't deburr it. So I have 3 different tools that I use. This is probably my favorite. This is a rotary deburrer, and it's designed for deburring holes. You just put it in the hole and rotate it around. You'll see a little bit of material cutting, and that's it. It's quick, it's fast, and it's effective. The other 2 methods that I have is a counterbore. So a counterbore tool, you would put it in and just rotate it back and forth. Although when I feel it, I don't really like it as much. The last would be a bearing scraper. So if you didn't have anything else, but you had a bearing scraper is a piece of tool steel that you can just put in on an angle and rotate throughout the hole, and it will deburr it. Now, we don't want to deburr this edge here. We can just put a slight chamfer on it using our bearing scraper. But we do want a relatively sharp edge, as our barrel is going to seat into this area and our head gasket is going to be sitting right here. The last thing that I've got to do is these cylinder heads need to be washed, and they are ready to go over to the assembly bench.